Yeah, I think we should start anyway, and then so Lars isn't coming. I don't know about Ardit and Brigger, but they have been coming in a bit late in the, in the morning, so they might still do that. I just want to say, even before they come, just make sure that it's those who are here in time get to hear it. So this week, I planned for the final set of presentations, but I had too many presentations probably, and Lars Bendik, he kind of called in sick, so he couldn't come today. So he was asking if he could present next week. And then Ardit was also saying yesterday that he thought he had quite a lot of papers, and so we might skip that paper. But that gives us 4 papers for today. And Lars Bendik, I planned on, or I have included his next week paper into the core set. So I think we will run that next week. But my idea for next week is not to, except for Lars Bendik's paper, not to go through any of these type of papers anymore, but have each one of you say a little bit about your survey, your report, your work, and see where you are at. We do that around the table to see where everyone's at, and have a discussion, and also share a bit what you've found so far. And then so that will be the program next week. So hopefully you all get to think about and just summarize briefly your presentation or your work so far. And if there are questions, anything we should discuss, then we can raise it at that point. When it comes to the core set of papers, I did go through what we've been covering so far, and as I said, with the exception of Lars Bendik's paper, which is not going to be presented the next time since he's sick. I think we've been through these papers with Marcus' presentation today, and also Ricken's paper today. I think we covered all the topics, and that this will then be the core set of papers that I expect for the oral exam. I expect you all to not know about the details, but the general issues being discussed in each of these, some of the general characteristics and the most important findings in these areas. This is going to be our core set. And then the other part of the exam will be more specifically on your report and your special topic, or what you decide to go in depth on.
So for the oral exam, we have to like.
You should know these papers.
So questions will be from these.
Some general questions from these, but as before, most of the questions will be from your report, clarifying what you did, because that's your specialization. But we want to have a little bit of breadth into this topic as well. So I covered some of what I think and hope is the more general type of papers in this. So don't worry. I mean, if there's an algorithm or is there an equation, don't worry about the details of algorithms and equations. Think about the general what you can learn the most from the papers.
But like I have to watch the payment permit, I have to go really into detail on that one, more than the other papers I select.
Sure, yeah, because that's part of the papers that I mean, if you shift it away, so if you don't say much about that payment architecture, no. I mean, if that is part of what is the core of your report, but it might be that some of the papers we chose early on aren't really that core. So let's say for Thomas. So if he went away from crawling into some more Ajax parsing or something, then the first paper may not be that relevant to his report. In that case, we wouldn't expect him to know more about his first paper than anyone else. So it's more, if that's an important paper in your in-depth study, then I expect you to know it more. But this is the core, and hopefully for most of you, the paper I picked from you is part of your core, and if it's not, or part of your specialization, and if it's a little bit on the side, I don't think you should spend more time on this than on the other core papers.
Yeah.
Answer the question? Yeah. Because, I mean, what we'll do, the first part is that we'll look at the report and focus on the report. And if this paper is part of what's being discussed, then of course it's something that you should know more in depth. If it's not that important. haven't gotten responses. I'm trying to get Simon or Mariusz to be the other examiner. I think it's most likely going to be Simon from their schedule, but I haven't gotten a response yet. So right now, I think that the exam will be between 10:30 and 4 o'clock, somewhere in that time range on the 12th, Wednesday 12th. And
12th October?
yes. Is there a conflict there? Or?
No,
I think
I thought that we had put on 13.
12 and or 13 is what they're saying, but I'm looking from their schedule. It seems that they are quite busy on the Thursday, so that's why I think it's most likely going to be on the 12th.
And the delivery for the report is the 7th.
Well, that's to be discussed here. I mean, it's a bit up to you. If you think you should have a little bit more, we can extend it to that Sunday. I'm probably not going to be reading a lot, so that's the weekend anyway. So we'll be reading the week starting from Monday. But that 17th is Wednesday. We can extend it to Friday or to Sunday if you want to have more time. Otherwise, if you're happy with the deadline, I'm happy that you give us a week to read. But I can, with 8 reports, you can read it a bit faster than that. So it's up to you.
Could we like have Friday until further notice, and like if it's a really big problem for a lot of us, we can extend it like in the last 2 days? Or do you want
I would like to set a date now.
Yeah.
And then we keep that date. So
I think we can extend it because we have at least the ones having mobile course have this kind of the same date for all our oral exam and project report also.
right. So you set Sunday?
Yeah.
Okay, perfect. Then if you're done on Friday, just
Yeah.
upload it on Friday. It's okay. I think that's about it. So next week, as I said, if you can prepare for that roundtable discussion, and so already next week, you should have some idea what the main body of knowledge will be and where you are heading.
And can we like send a draft to you for some?
Yeah, I mean the longer you wait sending the draft, the more likely it's going to be busy with the other draft. So as well. So yeah, but send me some initial ideas as soon as you have them, and then I'll try to get back to you as soon as I can. But the shorter you wait, the more busy I'm going to be, and the harder it's going to be for me to give you a response. But from before, I can say that I don't expect to get many. Many of you would want to have my feedback, but it requires that you have produced first, so you can get feedback. And the experience shows that not many students actually get to the point where they can give you much room for feedback. But okay, that's up to you. Yeah, I will answer whatever you try to send me, and might be a short answer if I'm running out of time.
Is there any example on what the report should contain, or any like examples of previous reports?
No, but we have been through a number of literature survey papers. So that's the structure. It's a literature survey paper. So, okay, this is the problem. This is the area, and we want to do a survey of the area. So you go through. Next chapter is to go through the main papers, and then you have a discussion, which is typically grouped into some sub problems, or then you conclude. So it's so you could pick any survey paper. I never asked any of the former students if I could hand out the report. So I think it's this is like any survey paper. That's what they expect you to produce. So we have seen a few. I think even next week, the Web of Things survey is kind of structure that you should follow. Any questions about the formalities? So yeah, these are the papers. And today, starting with Marcus. So Marcus, if you would like to take the stream, then you could go to your presentation.
Yeah, okay. I shared my document. Can you see it?
Yes.
Okay. Right. Mockup-driven development, providing agile support for model-driven web engineering.
Can you get this guy?
Just do double click for build also.
What did you say?
I was just trying to see if I can get it bigger here, but I don't think I can get the.
Oh, okay.
Oh, there you go. Okay. Yeah, a bit bigger.
Okay.
There you go.
Okay, the article starts by introducing model-driven web engineering process by some phases. we have to build a domain model. We have to define a hypertext model, and we have to define the look and feel of the application, as the user interface, and we have to generate code. Often UE is handled at the end of the process or late. And when customers see the application in action, it can result in changes. And changes in UI may result in changes of business requirements, usability, and so on. And this paper proposes a solution to this UE problem by using prototypes and mockups, wireframes, and so on, based on user stories. To boost efficiency and better communication. Then we have the 5 process steps. We have to create prototypes as models without discarding them or creating them again in a new tool. We have to annotate the prototypes with model-driven web engineering concepts. We have to generate WebML and UEE models, and we have to create a working application. By using this process, we can create iterative incremental software using small cycles. We use the mockups as UI specifications and incrementally enrich them to obtain the main model, the navigation model, and the presentation models. They propose a process for doing this called mockup DD, and they use HTML for mockups, but other models can be used as well. The process starts with a quick requirements gathering using user stories. We create mockups from each user story, and each mockup is mapped to a structural user interface model. A structural user interface model is a platform-independent model, meta model that can contain concepts such as simple widgets, container widgets, and pages, and so on. And all the requirements for the applications are specified using extensible tags. And the mockup and the structural user interface model can be combined to better show the semantics of the application. Then we have functional specification. This is done using tags. Tag is a name with one or more parameters, and each tag is atomic, or a standalone unit. Some tags are used only by a subset of the widgets. Every tag can customize, can define a custom syntax for each parameter, extending its semantics, and tag parameters can also contain domain objects such as a folder and so on. And we group tags into concerns such as navigation, data manipulation, and so on. Yeah. Tags are only conceptuals, and they will we refine them for each iteration. At the early stage, they are ambiguous, and they have to be redefined as we move on. And some refinements can be done automatically, heuristically, such as in using inferencing, and for object transfer between pages or units. And we have the last step is translating tags to model-driven web engineering elements. Yeah. So every iteration is about adding, removing, or refining tags. After this, we use model generators to create UV or WebML models from the structured user interface models.
Marcus, I was just wondering if you could blow or zoom in on figures 2 and 4 and maybe describe a little bit more detail. I mean, figure 2, the steps, and figure 4, the purpose of the tagging, so that they could see more clearly how the tags are being used in the code generation step. So starting in figure 2, just to describe the steps a little bit, and the graphic shows a little bit what the output of the steps are, and then in figure 4 a little bit more on the tags and the importance of the tags.
I don't think I can zoom in here.
Yeah, that's right. Sorry, I forgot. We had that problem last time as well. Sorry. But just show the figure and just explain the steps on the figure, and then everybody else can bring up that paper on their own computers.
Yeah, okay. In figure 2, we have step 1 with the mock-up construction here, where you use Balsamiq and HTML or something like that. And then you have the, in step 2, you have also from the mockup, you create a textual representation that you can process in step 2 and detect widgets, such as the container widgets and single widgets and so on. And then you have the, on the right-hand side, you have the SOE module that is created from a meta model and contains all the tags, I think, yeah. Yeah. Yeah, and you continue in step 3. You continue on specifying features by adding new tags or refining tags. You get some tags automatically from the previous step, and you have to add new ones yourself after that. And then you have a complete SV model in the end, which you can generate code from or additional models. Yeah. And you asked about a second figure as well, Runa?
Sorry, I was thinking of figure 6. Sorry, the figure where you have the tag sets and the tag structure, semantics, and the application for the tags. Just to give a little bit of understanding of why the tags are important for the code generation.
Yeah, well, each tag is atomic, so it can be handled on its own without relations to other tags. So you have different concepts that you can use to instruct the application of what it's supposed to do, such as this first one here. Sorry, I got the wrong page. So the first tag is about setting an ID for, I don't know, a page, yeah, page. And you can also create links to other pages. And you can specify data requirements using domain objects. And you can you can transfer to other pages by using buttons or links and so on. So everything is done by using tags. Yeah. Is that okay?
Yes, just go on.
Yeah. And here you can see in figure 7, you can see the complete mockup, HTML mockup, with the tags attached, so you can see what's going on. Yeah. Okay. Where did I stop? Sorry. Yeah, okay, you got it now. Yeah, okay. And to sum up the development process, I've used an ordinary Scrum process, but with prototypes and tag refinements focus instead of only using code. And after each iteration, we have a runnable demo of the application. And I'll also say something about tools used for the different parts of the process. I could use Balsamico or Pencil and so on to generate HTML representation. For the initial structured user interface model. And you also have a web-based tagging tool where you enrich the HTML mockup by highlighting and marking up elements from the DOM by using XPath for identifying source elements. And they also use the sandbox environment for running a demo of the application. So it's not a full application, but just a demo to show to the customer. To create the structured user interface model, they use the mockup processing engine. And some of the steps there are widget parsing, identification, and grouping per mockup. And also you have discovery of containment and relation between widgets. And you have, in the end, layer processing to resolve the internal graphical distribution and so on. And after doing an experiment, they concluded with that by using mockups, they improved the requirement gathering process, and tagging, refining tags, and running a demo improves the visibility of the project to stakeholders. and that mockups can be reused and not only used as an initial communication tool. Yeah, that's it. Thank you.
Yeah, very good. I think as you did, I mean the paper is quite long on the evaluation side, but I don't think that's the important thing. And the most important I feel is that the things we covered with the process, how the idea of having a mock-up, and that people like in model-driven development, it ends up very often being a waterfall model in which you can't test until the very end, but they suggest using the mock-up and then the whole process, and how tags are important to be able to generate the right semantics or the right functionality for each of the user interface elements. So yeah, and as I said, the details of their testing and evaluation, other than you might have added a remark saying that of course it was kind of positive on the type of applications they develop, but there are many more types of applications, so there might be a little bit of a bias towards the type of application they were testing on. So as always, more testing is needed to really say that this is a very useful approach.
I agree. It's the concept that is interesting, not the testing here.
Exactly.
So they also concluded with that it was a positive result. So it should be enough to read the conclusion on that part. Yeah.
Yes, very good. Okay, I think the next one up, Martin.
Yeah.
I promised to be early.
Yeah, you said I would be first, but that
yeah, you know, but with the distant one, I think it's always a good idea to yeah.
Just give me the VGA.
Yes, I will.
Thanks.
Let's see if we get to see the whole screen, or if I need to be further back. Need to be actually.
Yeah, it works. Okay, so I'm going to talk about this paper evaluating the monolithic and the microservice architecture pattern to deploy web applications in the cloud. It's a very short, brief paper, and what they do in this paper is that they developed two web applications, one using microservices and one using a monolithic approach. And they deploy this application on the Amazon Web Service cloud, and they run some performance tests on those two setups, and then they compare them and try and draw some conclusions. And they did this in cooperation with a local company where they have performed their studies. So as usual, they have the description of the microservice architecture pattern. They sort of dive into that one of the largest issues compared to, for example, monolithic architecture is that, especially if you're using a service-oriented architecture, you usually have this component in your system called the enterprise service bus, which is a way of messaging between different services inside your application. So the enterprise service bus was sort of a very monolithic component inside the architecture, and it wasn't really designed for what kind of use cases we might use it in today. So the enterprise service bus was usually designed to handle the load of, for example, a few hundred or a few thousand users. But today, you might even have the load of several thousands, if not millions, of users on your system. And then the ESB becomes the bottleneck in the architecture, especially if you're deploying to the cloud, because it's very difficult to add several instances to the enterprise service bus to handle more load. In some cases, that's not even possible due to the monolithic nature of the enterprise service bus. And they also discuss the service-oriented architecture pattern in contrast to microservices. And they highlight that there's a lot of discussion going on in academia and in the industry whether or not microservices is service-oriented architecture and what kind of properties they share and so on and so forth. And I would argue that SOA and microservices are distinguishable, but on the other hand, they share several properties which makes them quite different in how they operate and the thinking process between each one of the architectures. However, both of those architectures are so-called service-oriented, meaning that you have sort of like services that you build up and provide to the service consumers or those who could use your APIs or services. Oops. So some people argue that they are kind of the same, but ultimately that the microservices enables more agility due to the fact that it's far more flexible compared to service-oriented architecture, and that you're more free in what kind of approaches you can use. But on the other hand, you're also more restricted in terms of, for example, which communication protocols you can use outside of your system, because microservices favors a more homogeneous communication protocol approach, while service-oriented architecture may be even protocol agnostic, meaning that you could have integration towards several different systems. For example, if you have a banking system, you can easily integrate towards a Corba system using SOAP or whatever other protocol you might need, which becomes far more difficult in microservices. So back to the architecture itself. One component I haven't spoken about inside the microservice architecture pattern is the gateway component in the system, and this is a very vital component. As I mentioned earlier, in microservices, you split up your system into many different services, and each one of these services has a different endpoint between each other. And if the client were to communicate with these, they would have to know how to communicate with it. The problem is, if you have to know the exact endpoint to every one of these services, it would introduce a lot of coordination. And besides, there might be several instances of each service, meaning that one service might have several endpoints. To solve this, and to not having to have a dozen of different endpoints that the client has to coordinate towards, you have a gateway which abstracts this away from the client, so that the gateway knows which service to call for each API call, for example. So if you have, for example, a get user in your system, the get user is registered in the gateway, and then you have a user service, for example, inside your architecture, which then the gateway forwards the request to, and then the service will retrieve the user details and then return that to clients. Yes. So inside their case study, they have essentially two services that they discuss. And one has to do with calculating a payment plan based on number of payments and credit type and interest rates. And this is sort of a more heavily computational operation compared to the other one, which is to receive the unique ID of a payment plan that's stored in a database. So they had these two sort of like API endpoints or services that they are working with inside their application. So a general overview of their architecture. I can zoom in here a bit so it's easier to see. So this is their monolithic architecture. The front end is an Angular.js application, which displays the information retrieved from the from the web application. So here you can see they have the two different services, which was the calculation of the payment plan and the retrieving of the information from the database. So this is the monolithic architecture. So they have everything in one single monolith. And this monolith is implemented using, I think it was Play under Java. And the relational database was PostgreSQL, I think.
Maybe you could also comment a little bit on the service profiles, the table we have up to the left there.
Yeah, so this was sort of I think this was the expected load and the average and maximum response times on each one of these services.
Yeah, but so what they did was a mix of highly requested short transactions. So the S2 was, they were quite short, 300 milliseconds, but there were many of them.
Yes.
At the same time, you had these very much fewer, but they're much larger, and they could try to have a mix. Say, okay, in the monolithic, you have this mix of some infrequent large transaction and some much more frequent and shorter transactions.
Yes, I'll come back to that later on the results. And then they split this up into into the microservice architecture, where you have you still have the client on the front-end AngularJS application, and then you have the gateway, which knows about the two different services but doesn't contain the actual implementation of them. It only forwards the call to the actual microservice itself, which contains each one of these services. And this is how they deployed the monolithic architecture on the Amazon cloud. So they have a load balancer in front of several instances of the monolith. So they have a similar approach here on the microservice deployments, where they have several instances of the gateway itself, but then you can independently scale each one of the services. And this is one of the main differences between microservices and monolithic architectures, because this service here is very heavily computational. Well, this one is not. This involves more I/O compared to this one, but this one will in most cases be most expensive. So therefore, it's a waste of resources to scale this one if you need more resources on the first service. Yeah, I find it a bit interesting that they choose AngularJS just because it's supported by Google, but that's another case. They use Play, as I mentioned earlier. They also use Netty for the networking, if any one of you have heard about it. And what I find a bit lacking about this paper is that they have a very different configuration on both of these setups. So on Amazon, you have different configurations for each server that you can deploy your systems on. You have, for example, small, medium, and large server that you can deploy on. And these ones have they cost different cost models. They have different certain amount of RAM and CPU and so on and so forth, different cores, and they have only on the monolithic, they have extra large instance, and on the microservice, they have a medium instance on the gateway, while they still keep an extra large instance on the computationally intensive component in the system, while on the database specific one, they have a medium instance. Now, I would argue that this might introduce bias in terms of the performance results. However, I'll come back to that later, because I would argue that it's not very externally valid considering the configuration. They also argued that with microservices, you might save a couple of bucks due to the configuration of the system. However, this will totally depend on the system itself. It doesn't exactly say that, yes, microservices are going to save you money, because it depends on your architecture.
And the profile of the requests.
Exactly. And they also mentioned that they use JMeter, which was, I believe it was an Amazon service to mention the request rates. So here's the actual results of the monolithic and the microservice architecture response times. So as you can see, the microservice was a bit slower on the first service, but it was a bit faster on the second service. And I would argue that this is mostly due to the configuration that they have on their system, but also because it involves extra transport time between the different components in the system. Yeah, they also mention here that when you use microservices, that service versioning is very important, which means that each client might use a different version of your API, and that this can introduce a lot of problems inside your API design and so on and so forth. Another important aspect is the use of DevOps, which means that the developers themselves manages the services once they have been deployed to production. Yeah, I think that's it. They also conclude that microservices is more easier for a more complex system, which is very large, because if you have a very large system, a very huge monolithic system, it becomes very difficult to change and modify the code base, because it becomes very, very dense and dependent on each other. And if you were to change one single little detail inside the monolith, you would have to deploy the entire thing over again and redeploy everything. Another comment I would like to make on this this paper or their case study is that they have a very limited view on the microservice architecture, because in the microservice architecture, you have usually more than 2 services. You can have tens or 20 services in some cases, and you also have communication between these services. For example, you might have a service that might need to perform a transaction, and that can also have an impact on performance. So I would argue that this paper is extremely limited in terms of external validity, because they only test on 2 services using the Java Play framework on the Amazon web service platform with this specific configuration on the different components. So I would argue that some of their conclusions are valid, but I wouldn't argue that it adds much to the value of the paper by, for example, listing how much it costs to deploy a microservice versus a monolithic architecture. Also, the response times is biased because of the external validity and the limits of configurations in their architecture. Yeah.
That is indeed the limitations of a case study, is that you can interpret and understand that case.
Yeah.
Now, to get the more of a general understanding, you need many such cases,
Yes.
and then you look at the average and look at the characteristics. So what these guys could have done was, of course, then to, as you suggested, run the 2 services on an identical setup to see how they would perform if the the two servers are set up identically, and then at the same time say, okay, but we could save money by doing these changes, and then we get these results, and then you had at least 2 data points to compare and discuss. So,
but they say here in general, evaluating the monolithic and microservice architecture pattern, and that involves more than the actual deployed system. For example, in the microservice architecture pattern, you have this entire pipeline. When you change something on your code, everything should be automated from when you push something to Git until something gets deployed on, for example, Amazon Web Services, which they briefly just mentioned in the article.
Sure. But I would say it's interesting to have at least some more some papers that actually look at the implementation and some of the observations, but we need many more to draw any good conclusions, as you're saying. Okay.
Yeah.
Maybe we have a 10-minute break and then we continue a couple of more papers after the break.
Ja, sorry.
Har du lyd? Takk. Takk. Hallo? Hallo? Hallo?